welcome back everybody to IFB 104 Building IT Systems. And we're up to lecture number 6, which means we're about halfway, which is good because it means the end will soon be in sight. This week's topic is relevant not to assignment 1, but it is relevant to assignment 2. So it's not too soon to start thinking about what we need to do for assignment 2, even though you're still working on assignment 1. Assignment 2, of course, is due in week 13, so it seems like a long way away, but it's not a long way away in terms of learning the stuff you need to know in order to solve the problem. So we need to move on to assignment 2 topics fairly quickly. And this one is about how to create user interfaces, which I think is one of the more interesting topics in terms of demystifying information technology, because you see user interfaces on your laptop computers or on your desktop computer all the time, and they seem like magic, and now you're going to discover that they're not magic at all, and in fact you can create your own user interfaces quite easily in Python, as it turns out. So, housekeeping things, as usual, there's a quiz, keep up with them, they're always coming out on Thursdays, and they're always due on Wednesdays, except for the weeks when the big assignments are due, of course. That would be too cruel, having 2 assessment items due in a week. I wrote on this slide, I had fingers crossed that the Test 2 results would be released by now. They have been, fortunately, so that prediction came true, which is quite nice. I wouldn't expect any major dramas with that particular test, because it's fairly straightforward. You know if you manage to draw the thing successfully or not. But if you've got any problems, email ifb104.query at qut.edu.au. The other thing, of course, is to keep working on assignment 1, part A. You know what part A is, you don't know what part B is. You will find out what part B is on Monday morning at 9 o'clock on week 8, and you'll discover, hey, this is easy. It's not as scary as I thought, and it's only worth 5%, so it's not a big deal. But it will test your ability to do a quick addition to your previous solution. As I was discussing with somebody last week, it's an extension, it's not a change, so it won't change any of the code you've written so far, so you don't have to worry about that, but it will add something quite noticeable to your existing code. The other thing is that Stimulate people have been bugging me yet again, saying, why aren't students coming to ask us questions? So just a reminder that the Stimulate is always there, but they have particular sessions for IFB 104, which run according to this on Mondays and Wednesdays, and they continue to say that they're underwhelmed by the number of students seeking help. So if you've got problems, go and talk to them. They're very happy to talk to you. They run these group sessions more like tutorials than the workshops that we normally do. So they go through the lecture materials and the various concepts in there, and they'll give you additional advice on anything that you didn't get first time around. And otherwise, just drop into Stimulate at any time, because they're always available. And that timetable is on Blackboard under unit details if you can't remember all of those times. What else have we got? Oh, yes, we have one other thing before we actually get started this week, and that's feedback. So, many people were kind enough to give us some feedback via the Pulse survey. So, as I mentioned quite early on, you'll get a lot of surveys during the semester. Pulse is the one you've just done, which is taking the pulse of the unit early in the semester. The next one you'll get is Spot, Student Perception of Teaching, which is a survey about particular teachers, so it gives you a chance to comment either on me or on your various workshop facilitators. And at the end of the semester, there's another one called Insight, which is what did you think of the unit as a whole. So as I say, surveyed to death, but we do appreciate getting your comments back because they help us improve the unit. So what have we got in the Pulse survey? Well, we got a lot of comments. I certainly couldn't possibly reproduce them all, but that's good. The one I put up at the very beginning here was the one that made me happiest, because this is a person who is benefiting from this unit, and it's exactly the sort of person the unit is designed for. While I have no background in the field, I am learning a lot. And the person went on to say that they've never coded or programmed before, and they're learning something from this unit. And I emphasise that that is what this unit is about. It's a no prerequisite first year, first semester unit for people who have never written a line of code in their lives. So a lot of the other comments that we got were, I hate this unit, it's so darned easy. Well, that's not my fault. If you know this stuff already, I'm not quite sure why you're doing this unit as an elective anyway. But this unit is designed for people who have never coded before, and that's exactly the reaction we want to get out of them, is I haven't done this before, but I'm starting to get the idea. Somebody made an interesting comment, would prefer to learn about if statements first rather than making our own functions. Very perceptive, because the way we introduce topics in this unit is peculiar. Normally in a unit like this you would introduce function definitions after you've done if statements and for each loops and things like that. The reason we do it this way though is so that you can get straight into playing with turtle graphics, because my feeling is that drawing pictures is much more fun than looking at text, and so we need to introduce the turtle functions in order to do that. So it is an unusual order of presentation, I agree, and I think this person was quite perceptive to note that. Somebody else made a comment which is worth responding to. The unit doesn't seem to have much theory, which makes me slightly worried about what they'll assess in the theory exam. Very good point, because in QUT terminology, the end of semester exam is a theory exam. You'll actually see it written on the exam paper. This is a theory exam. Well, that's just terminology. That's just what QUT calls exams. They're testing theory. There is no theory in this unit. I haven't said anything of a theoretical nature regarding computer science or programming here, and that's not what we're going to be testing in the final exam anyway. The final exam is very much like the quiz questions you're doing each week. It's a test of what you are capable of doing with small code segments, or what you understand about small code segments. And in fact, the exam questions are much easier than the weekly quiz questions because you don't have a computer in front of you. We know that. So we make the questions easier. So you will see a reference probably in your timetables or something like that to the theory exam. It's not a theory exam. It's got nothing to do with theory at all. And of course, the Week 13 workshop is 100% dedicated to the practice exam. So you'll know exactly what's on the exam when you go into it. There's a few comments from people who are just bored with a slow delivery, and again I go back to the point that this is meant for beginners, complete novices. And this person says, half an hour on Code Academy gives me 3 lectures worth of content. Yes, I agree 100% with that, and if you find some online resources that are better than listening to me yell at you in a lecture theatre, please use them. There's no reason to assume that the only way you can learn stuff is by listening to me. So make use of our online resources as much as possible. You will find, though, that after this point in the semester we're veering off onto topics which might not be covered in those sorts of areas. But make good use of online content wherever you can. If you find something good online, let everybody else know about it. Let me know about it, because it might be something I can point other students to. At the opposite extreme, of course, we get these sorts of comments. I find the subject extremely challenging. It is almost impossible to keep up. And again, from my point of view, those are the students that I'm trying to focus on, the ones who are not saying this is too easy, I've done it all before. It's the students who are in that boat who need the most help. And they're the ones that all of the workshop exercises and all of the lecture materials are targeted towards. Another very insightful comment was somebody who whinged a lot about, I hate Turtle, or why are we playing around with Turtle graphics? And then they said, TK-Inter could be used instead, and it should be spread through the semester, and we should do assignments using TK-Inter instead of Turtle. Guess what today's topic is? TK-Inter instead of Turtle. So assignment 2 will be using TK-Inter instead of Turtle, so this person must have read our minds. Can the lecturer please try to be more engaging? Well, I'll do handstands and backflips if you like, but it's not going to be a pretty sight. But I'll attempt to do it. And of course, as we all know, the lectures are mind-numbingly boring, with the lecturer, I assume that's meant to be, sticking to a slide reading in a monotone voice. Okay, let's do it again. Let's have another mind-numbingly boring lecture. And I'll read out the slides in a monotone voice. So, here we go. Aims of this week's lecture are to introduce graphical user interfaces. So, by the way, any questions at this point? Problems with the assignment? I think these folks in the room here are all pretty good on the assignment, so you know what you're doing. The one thing I would point out is it's due in only 2 weeks. Let me find my slide again. So only 2 weeks to go before the assignment's due, so you should be making good progress on it by now. If you're not, get stuck into it, because there's not much time left. Okay, this week's lecture, GUIs. GUI, G-U-I, Graphical User Interface, pronounced GUI, are the things that you see on your desktop computer when windows pop up and you do stuff in them. So GUIs are actually the main old-fashioned dinosaur user interface that all modern computers actually still use. So everybody I can see with a laptop open in front of them is looking at a GUI. And mobile phones and tablets and so on also have GUIs, but they're a slightly simplified form. But basically it's all about popping up windows containing what are called widgets. So you might not realise it, but those buttons and other labels and things that you see in your windows on your desktop are known as widgets. And the question is, how can you create them? We'll find out today how you can create your own widgets. Also, as we do that, it makes us start thinking about what makes a good user interface, because now we're talking to human beings. Now, that's not the topic for this particular unit, teaching unit, but it is a human-computer interaction topic of general interest. So in other units involving design, you would be thinking more about how do I design a user interface so that it looks nice and is easy to use. But at this point, you might actually start thinking about what makes a good user interface. And there are plenty of general references out there, as it says on the slide. So there are examples of using tkinter in Python. So have a look at those if you need to. And the other thing I would say about references is most of the semester I've been pointing you towards the standard Python documentation. This is one topic which I think is described really, really badly in the standard Python documentation. They've got, even in the reference manual, they sort of say this is a work in progress and it's not very good. So I just go online when I'm looking for stuff under this heading, tkinter. I just Google Python tkinter and up comes the answer every time, because this is all about looking up how to create a widget, what sort of properties that widget can take. It's a fairly tedious process of just finding the right magic incantation to get things to happen. So two sites that tend to pop up at the top of my Google searches are the ones shown here, the old one called FBOT tkinter book. I don't think that's been updated in about 10 years, but it's still relevant and it's still a very useful reference because it just gives you a long list of the things you can do with each of these tkinter widgets. If you want a sort of tutorial introduction, there's one mentioned there, and I'm sure you could find lots and lots of others as well, because this is a topic that's been around since the dawn of time. The particular module we're going to be using called tkinter is implemented in just about every programming language and goes way, way back to the early days of graphical user interfaces, so it's easy to get information on this. Just to put things in context again, I put up this map at the start of the semester saying these are the topics we're going to cover. We've now finally reached the point where we move away from the middle of the map. So up until now we've been doing the basics of computation using Python and Turtle just to illustrate things visually. Now we've gone down to the right hand corner. So we're going to look at human-computer interaction using tkinter. There's only going to be this one lecture on this particular topic, but we're going to keep using this stuff for the rest of the semester. So it's a topic which introduces the whole notion of interaction with human beings and people talking to our Python programs. Later in the semester, we'll be looking at interacting with databases, and we'll also be looking at interacting with web pages via HTML. But at the moment, we've finally moved away from the centre of the diagram and we've gone down to the bottom right-hand part. So tkinter, I've mentioned a few times. Just what is it? Well, first of all, what can it do? So let's find a demo. Pop-up windows. Okay, so pop-up windows is a stupid little program that does something that you haven't been able to do before in your Python exercises. And let's see what it does. He says, struggling to find the button. Okay, this is what it does. It creates this. It created a window. And that's the first time we've ever actually done that, a program that creates windows. Not only did it create a window, it's a window containing two things. Picture of a jack-in-the-box and a button that says press me. So this is actually a window containing two widgets. And widgets are things that you can sometimes interact with. In this case, I can press the button that says press me and something happens. Another one pops up and I press it again, and another one, and another one, and another one, and another one. and it just keeps on doing that. And I can grab any of those windows that pop up and press the button on that, and I'll get still more, because they're all the same, because it's an example of recursion. So remember when I was talking about iteration the other week, I talked about recursive functions, functions that call themselves, and these stupid jack-in-the-boxes are functions that call themselves. Every time you press the button, you get the same thing. However, I can get rid of them all by manually closing them down. It's going to take me a while to find them. Or, as I just did, find the root window and close it down, and everything else gets shut down. So that was an example of a tkinter program, a program that creates windows, and within those windows, the windows contain widgets, and widgets are typically buttons, menus, things called spin boxes, anything that you can interact with as a human user of a system. So there's an example there on that slide, actually, which is a complete tkinter program. So if we just have a quick look at the slide, you know, I go through slides in a boring monotone, as you know. So on that slide is a 100% complete tkinter program that creates the little window down the bottom right-hand corner. So we import from a module called tkinter all of these different functions that we need. So it's just the same as Turtle Graphics. And the other thing I'd point out, you don't realise it, but you've been using tkinter all semester because Turtle Graphics is written using tkinter. You can develop your own Turtle Graphics module using tkinter. So the way Turtle Graphics, when you say create a drawing canvas for me, it pops up a window. How does it do that? Well, if you look at the code that Turtle Graphics is written in, it's actually using tkinter to create that window. Because tkinter, the TK interface, is an interface to the operating system. And that's another important thing here with this demo I just gave you. When I ran that program and the jack-in-the-box appeared, okay, it looked like the sort of windows I have on my Apple Mac computer here, which is about 10 years old and is running Snow Leopard, a very old version of Mac OS X. And so you notice that it has buttons which allow me to minimise and maximise things. So maximise, I can hide things away where I can't find them. What happens if I press that again? I get it back to the normal size, and I can shut it down. But I didn't ask for any of those things, those three buttons that allow me to maximise, minimise, and shut down the window, because they come with the operating system by default. And of course, if I ran this piece of code shown here on a Microsoft Windows operating system, it would look different. It would have a different look and feel, because for a start, the buttons that do those jobs would be on the right-hand side, and they'd be square instead of round, and use different colours. So when we're creating windows like this, unlike some of the stuff we've done before, we're interacting directly with the operating system by saying, create a window for me. And we can put various things into the window. We can ask for different colours and so on. Sometimes the things we ask for are refused. For instance, there's a button there on this example. And if I run this piece of code in, on a Mac, you get a certain colour of button. If I run it under Microsoft Windows, I get a different colour and style of button. The button still does the same job, but the look and feel are different. And I sometimes have slightly different things I can control. On a Windows system, I can change the foreground and background colour of the button. If I do that on a Mac, it just ignores me, because the designers of the Mac operating system have said all buttons are going to be grey, and when you press them in this particular version of Mac OS X, they highlight in blue and so on. So some things are fixed, some things you can control. It's up to the people who implemented the particular version of TK on their particular operating system, and you'll get a different appearance under Linux as well. So not everything about these windows that you can create is under your control. Some of it is predefined by the operating system. But if you look at the, I might as well start building up some code. And what's it going to do this? Okay, yeah, okay. I'll just do a very, very simple example of creating something. I won't go back into that one. So if we want to create our own tkinter programs, as usual, document what you're doing, tkinter demo. All you have to do really is from tkinter import everything. You've done that a million times with Turtle, so the same sort of thing. And the most basic thing I can do is say, give me a TK window. So capital T, for reasons that aren't very important, but it's actually a class, and this is a constructor, but you don't need to know too much about that. Treat it as a function, and it's a function that will, when executed, create a window. Now let's see what happens if I run this program just as it is. It's going to bug me with that annoying prompt, and I'm going to call it demo.py. Okay, save. And what happens? I get a window popping up. It's not much of a window though. It's got nothing in it for a start. It's got a default title, TK, because this is the TK API, programming environment. And that's about all it does. The only thing it can do with this window are the defaults which are applicable to any window on this operating system. So I can resize it by stretching it open. As I did before, I can maximize it, or I can shut it down. So I get all of those behaviours for free. If I want anything else, I've got to put some widgets into this window which do something. So how can I do that? Well, first of all, you wouldn't normally just create the window like that. You would normally assign the result of creating that window to a variable so that you can make subsequent changes. So let me just document what's going on here. Create a window, and I'm going to give it a name by assigning it to a variable. So I'm going to call it screen. Okay, so that's my window, and I've now given it a name so that I can refer to it. And the first thing you would normally want to do with a window is give the give the window a title. Okay, and the way to do that is to call one of the methods that are applicable to these window objects. So in this case, one of the things you can do with a window is give it a title. In this case, I'm just going to call it demonstration, if I can type the word correctly. No, I can't. Demonstration. Okay. So if I now run this again, I should just see the same window popping up with a new title. And I do. So there's my window again. Still just a default size and got nothing inside of it. The other thing I can do, though, is put stuff into it. So how do I do that? Well, for instance, things like buttons. So I can put a button into this window. First of all, I have to create the button. So one of the things that's in the tkinter kit, it allows me to create a button. And in the same way TK was capital T, the buttons are capital letters as well. So if I say button, I need some parameters, and as it says there in the tooltip, the first one is the master, meaning the window in which this button will appear. So I need to specify which window it will appear in, because as you saw with the pop-ups demo, I can create lots of windows. Which one do I want to put this button into? Well, this button's going to go onto my window I've called screen, so I'll just say screen. And normally if you create a button, you put some text in it to say what to do with it. So there's another parameter here, which is the text that goes into the button, and I'll just say push me. Okay, and close that. This program should work, I hope. Let's find out. It does, but the button didn't appear. Why not? Because I didn't say what to do with the button. I created a button, but I didn't actually say where it should go or how it should behave. So I need to improve on that. Again, in order to allow me to refer to the button, I'll give it a name. So, I don't know, I'll call it pushed. I don't know why. It's put because it's pushed around. So I've given the button a name now, and I can put the button into the window. So put the button in the window. Okay, and the way you do that is by default to pack the button into the window. Why pack? Well, we'll find out a bit later on when we look at geometry management. But the default way of putting something into a window is to call a method called pack, which means pack it into the window now that you've created it. And so this demo should work as is as well. And I finally get my button appearing. As you can see, it's It's really, really small. The other thing that's happened is the whole window has been resized to fit the contents. Now that we have some contents in the window, I get this really tiny window that is just big enough to accommodate the button and nothing else, because I don't have anything else in this window. So by default, the window's size is as big as the contents. But we can change that, and we'll get onto that in a moment. The other thing is, because it's a button, I should be able to push it and exciting things should happen. And I can push it, but nothing happens at all, because I haven't said what to do when somebody pushes the button. But you can see that it does light up in this particular version of Mac OS X. If I run this under Sierra, the latest version of Mac OS, the Mac OS operating system, it doesn't light up at all, because whoever designed that version decided, no, buttons don't light up when you push them. And if you do it under Windows, depending on which version of Windows you're using, you might get a different visual effect. Completely out of my control at this stage, because I haven't actually specified how to do all those things. But there's a very small program that does something. The other thing that I haven't done is this last line here. And I don't seem to need to in this particular TK implementation, but being a very cautious person, I will do it. And that's the last step, is normally start the event loop, in which case you nominate the screen of interest and you say main loop, which is another built-in method. And that's the one that says, okay, we've set the window up now, we're ready to start responding to inputs from the user. Now, I don't know if in different implementations of TK you can get away with not doing this by default, but as a cautious programmer, I always start my programs up in TK-Inter by doing this, create the window, and at the end of the program, I always start up the main loop, just in case it's not the default behaviour. Because this program, although it doesn't look like it, it is responding to my button presses. It's just that I haven't said what to do when somebody presses the button. So the general pattern, as on the slide and as on this example, is you would typically create a window like that, and then you do some stuff, put some stuff into the window, and then start what's called the event loop, which I'll mention again in a moment, to get the thing going. Because the other thing that's different about this program compared to all of the ones that you've been developing in the workshop so far, I might as well mention it straight away while I've got the slides here, is that this is an interactive or reactive program. So the event loop, I keep referring to, is the way these programs respond to events that the user initiates. In the programs you've been writing so far, you say run module, and the program runs and it terminates. So it runs to completion. These programs are different, because in this case, once you start the event loop, as it says in that flowchart, it waits until some event occurs. An event is the human being doing something, such as pressing a button or opening up a menu or typing some text into a box. And then you process that event, you respond to it, and you go back and do it again, unless the event was to close the window down. So pressing the red button up the top left or the top right and under Windows closes the window, in which case you just terminate. So these programs, generally speaking, just sit there doing nothing when you start them up. They'll create a window and stop, and they'll wait for you to do something. So we're in the world of interactive or reactive programs at this stage. The other thing I haven't been very clear about is what do I mean by a GUI, and this is a typical GUI, obviously a Microsoft Windows one in this case, using an old version of Microsoft Windows by the looks of it. A GUI is just a window containing lots of widgets. They are really called widgets, I didn't just make that up. So we've got a window here, and it's got a variety of widgets. It's got, for instance, a label. A label is normally a fixed piece of text, but in that pop-up demo at the beginning with the Jack in the Box, that Jack in the Box image was a label. So labels can be images as well, or pictures. But they normally don't change, although as you're about to see, we can change them. You've got text entry fields. So that's where you can type things at the keyboard and enter them into your program. You've got various sorts of buttons. So this is a good example because it's got a variety of buttons. We've got a check button. They're the ones that you can toggle on or off. You've got radio buttons. Radio buttons are the ones where you can select only one out of a group of buttons, and the ones you've already seen me playing with are just standard push buttons, where when you push them, something normally happens, although nothing did in this particular case. There's one other thing in this image as well, and that's the frame. The frame there surrounding the radio buttons is like a little sub-window. So this is a way that you can organise these widgets to make them look nice, is to arrange them in sub-windows and arrange them side by side or on top of one another and so on. So we'll see how that comes up. And that's the human-computer interface sort of part of it. It's not just a matter of creating these things and leaving them. You have to actually arrange them so that they look nice and so that they're self-explanatory and easy to find. There's a little demo here called Frustrating Button, but I don't think... I know what I'm going to do with this one. I'm going to change it. So Frustrating Button is one of your predefined demos, so yes, but it's called Frustrating Button for a very good reason. Here it is. It's very similar to the one I just did, which is why I was not sure whether I was going to do it or not. So I've got the whole program on the screen there. It says create a window called the window, give the window a title, TK Demo. It then creates two different widgets. Okay, so one of them is a label. We haven't seen this before. Capital L label is a label where I specify what goes in, which window the label goes in, and I also specify the text that appears in that label. In this case, it's the word frustration. And another optional parameter is I can change the font. So I can make this label fairly large. Also create a button which has the text push me on it, slightly different. After creating both of those widgets, I then put them into the window by packing them. I'll explain what packing is in a moment. And then I start up the main loop to respond to events that I perform. So this is almost the same as the example I just did. It's slightly different though because it looks a bit better. And it pops up a window like this. It says TK Demo. It's got a label frustration, and it's got a big button that says push me. So it's a bit easier to read than the previous one because I've made the text a little bit bigger. The problem is when I push the button, still nothing happens. So what can we do about that? We need to specify what to do when the button is pushed. So in this case, the way of telling a button widget what to do is to specify what command it should perform when the button is pressed. So, as another optional parameter, when I create the button, I can say the command is to, trying to think of a good example, is to print a message. Okay, so I've specified not only do I want this button with text of a certain size, but when somebody pushes the button, a message should be printed. If I run this program now, it's obviously not going to work. Why not? Because it says name print message is not defined. So what is print message? Well, print message is going to be a function. So the simplest form of interaction that you can create in these TK Inter programs is to associate a function with a button. That's an easy thing to do. So I better write the function that does something when the button is pressed. So define what to do when the button is pressed. And the way you do that is just a standard function definition. You've seen those before. But the difference here is it's a parameterless function because I haven't actually got a way yet of passing values to it. So it's called print message, but no parameters. And then I can just say whatever I like in here to define what this particular button does. So I'm just going to print a message. So I'm just going to print ouch whenever anybody presses the button. And now this program should actually work. Function F5. So here's my previously frustrating button. It's no longer as frustrating as it was because if I push the button, I get the message ouch appearing in the shell window. Not a very useful thing to do, but it is a demonstration that I can interact with this window to do something, creating lots of ouches. There are other things I could get this to do. For instance, I can get it to interact with one of the other widgets in the window, which in this case, we've only got another one, the label. So I can, for instance, change the label. So it's a bit odd looking, but the way you do that is you mention the thing, say the label. I want to change its text property, so these are actually called properties, and I want to change the text property to ouch. So now when I press the button, I won't get something printed in the shell window. I should get the label in the little pop-up window here to change. Let's see if that actually works. Oops, what have I done? Pressed the wrong button again. Okay, we'll start our program up. So keep an eye on the label that currently says frustration. When I push the button this time, it changes to ouch. But if I push it again, I don't see any change because it's just setting it to ouch over and over again. The other thing you noticed is that, again, excuse me, by default, the window changed size. So by default, the window is as big as its contents. So in this case, when I ran the program initially, it was big enough to accommodate the word frustration. When I pushed the button, it became smaller because it only had the word ouch in it. That's an incredibly annoying thing for a user when windows change size and widgets move around. You want to avoid that, so you normally would fix the size of the window so that that can't happen. So one way you can do that is by setting the window's geometry. So I'm getting way ahead of myself here, but I might as well do it while I've got this demo running. So fix the window's size, and the way you do that is to say the window dot geometry, and you specify what X and Y coordinates it should have, or size it should have. And so I'm just guessing, but I'll make it 200 pixels wide by 100 pixels high. Let's see what that does. So I'll run it again. Okay, and as you can see, I've got a bigger window now. Not a bad guess, actually. And when I push the button this time, the window doesn't change size. So by saying exactly what size I want, I don't get the usual default. So obviously, as you start to build these programs up, you get very, very picky about where things go and what sizes they are and so on in order to make it look nice. And that's one of the things that makes this whole TK-Inter business seem complicated. It's not complicated, but you have to say a lot of things. You have to say, I want this widget here, I want it to do this, I want it to be this big, I want its colour to be something else, and so you have to specify lots of stuff, but it's not fundamentally complicated. We'll get back to formatting Windows nicely in a moment, but let's continue on with some of the things we can do with these kind of windows. So let's get rid of frustrating button. There's another demo that I'll just put up straight away because it's a direct follow-on from the one I just did, and that's display bits. Quite a few of the demos this week are pre-packaged because it's going to take me forever to type them all in. So display bits is a variation of what we just saw, but it's something that's a little bit more useful and has some other kinds of widgets in it. So I'm just scrolling through the code now. That's all there is. So it's not a lot of code. Let me see if I can get it all on the screen at once. Just about. Yep, so that's the whole program. So it's not big, but let's see what it does. Function F5. Okay, so this one pops up a window which looks similar to the ones we had before. It's got some big square area in it here, and it's got two buttons labelled 0 and 1. And it's called display bits, so these bits must be the binary digits we're talking about. And if I press the button 0, a 0 appears. And if I do it again, another one appears, and another one, and another one. And if I start pressing the 1 button, 1s appear, and there's another 0. I've now got 8 of them. So I've filled up that line, and if I press 1 this time, it now appears on the next line. So I'm getting 8 bits per line, which is pretty typical in computing. And that's all I can do. I can press buttons and keep filling up this little area here. What happens when it does fill up entirely? So let's find out. I've completely filled it now. I'm going to press the button once more. Something magical will happen. We get a little scroll bar appear so that I can scroll down to see the rest of it as I press more buttons. So again, all of this stuff that you see happening on your desktop is not magic. I can write little programs that do these things myself. So what have we actually got in this particular program that allows me to create this rather dull behaviour? It's all of the code is there. That's the whole program. We create the window as usual. We start off the event loop to respond to my button presses every time. Then we create 3 widgets. So if you look at this thing, it's got this area as a widget and it's got 2 buttons. So you can see down here is where we create the buttons, and that's the same as the examples we just did. There's a button called 0, which is associated with the function display 0. So every time I push the button 0, that function gets called. A button called 1, which has the text 1 in it, and when I press that button, the function called display 1 gets called. But where does the stuff get displayed? The stuff gets displayed in this thing, a scrolled text widget. So this is one we haven't seen before. So this thing with the little scroll bar on the side is a widget called scrolled text. Now this particular one is from a slightly different module. So I haven't actually said tkinter gives you some very simple widgets. So there's a standard set that you'll find on any computer, but you can get extensions to those and you get extra add-on modules. So scrolled text is not one you get by default, you have to ask for it. In this case I've specified from the tkinter module under scrolled text we want this scrolled text widget, but it's clearly not one of the standard default ones. Excuse me. And the other important part about this one is, how do we get the text, the 0s and the 1s, to appear over here in this box? Well, when the buttons are pressed, they call this function, and this function inserts, so insert is a method associated with scrolled text widgets, at the end of the text. Okay, so we specify where we want to insert something, in this case a 0, just as a character string. So the scrolled text widget was created up here. We said we wanted a scrolled text widget. It sits in our window. Font is pretty big. I said there were 8 characters fit on a line, and that's because I said so. I said I want the width of this to be 8 characters wide, and 4 lines high, and that's exactly what it is. It's 8 characters wide and 4 lines high. There's a border on this, so you can see when I click on it, it's got a black border around it. That's because I said I want a border of width 2 pixels, and I want that border in a particular style, which is groove. But if I ran this on a Microsoft Windows machine, it would probably look different in some way. Certainly wouldn't have this funky looking scroll bar here on Windows. It would be different, and it's different on a more recent version of Mac OS X as well. So this is all, they're still under the operating system's control generally. But the most important thing is this scrolled text widget has a name. It's called display, and so I can refer to it in other parts of the program to do things to it. In this particular case, to insert text into the widget. Okay, so, and the last thing is, remember, every time you create a widget, you have to say that you want to insert it into the window, and that's what these things are doing. Display.pack, button0.pack, button1.pack. Notice that they appear in the order that's specified here. The display appears first, button 0 appears second, button 1 appears third, because when you pack things into a window, they just go in from top to bottom, exactly as you specified. So you don't have a lot of control if you're using what's called the Pack Geometry Manager over the way things are laid out. But after the break, we'll see how we can actually change that. Now, speaking of, where are we up to in the story? So I'm rushing through this a bit, but it's fairly basic stuff, and you learn it through experimentation, just trying these things out. Okay, so I've shown you a few widgets. There's a whole lot more. So there's we've seen buttons. We just saw a scrolled text widget. That's not even mentioned here, but we've seen labels. You can have a canvas for drawing in. That's how Turtle Graphics was created. It's a tkinter application that creates a canvas that you can draw on, and it's written using exactly these functions and methods that you're seeing now. Check buttons, we'll see some examples of these a bit later on. Text entry fields, and so on. So these are pretty standard ones, radio buttons, but there are a lot more, and you can import other modules to get even more if you want to do that. One of the workshop exercises for this week asks you to use a progress bar. Remember, those are those things you see showing the progress of some computation, and you can control those yourselves, so that's an interesting one. as well as having this whole collection of standard tkinter widgets, and there's a lot more than I've got on the slide here, each of those widgets has different properties that I can set. So you saw in the example that was just on the screen and is now gone, display bits, that I can specify as optional arguments different properties of each of the widgets. So in the case of the scrolled text one, I could specify its width and height, and whether it's got a border around it and so on, and what font it has. And with the buttons, I specified the text that appears on the button, and again the font size, and what command to call when the button is pressed. So every widget has its own different list of properties that you can set, and that's why some of those online references I mentioned before are really helpful, particularly that FBOT one, even though it hasn't been updated in 10 years. So this one here, the tkinter book, it's just a reference that has the list of all the properties you can set for different widgets that you can play with in tkinter. It's really helpful to be able to look that up very quickly. So they're the standard widgets, plus many more. And so there are standard properties as well, but not every widget will have all of these properties. And one of the frustrations of playing this game is you can never remember which properties are associated with which widgets. But some of the ones that would be common to most widgets are things like FG for the foreground colour, BG for the background colour, text, if the widget has text associated with it, what text do you display, the command that you call, the font you've seen. You can align text left or right or centre it using Justify. You can change the cursor style. I don't actually have any demos of that, but you've seen when you're playing around with a desktop or laptop computer that when you move the cursor into different applications, the little icon representing the cursor changes. You can set that as well. And we'll get on to variables and values which allow us to communicate data between widgets in a moment. One of the things that you can do, though, having created a widget and specified its properties, is that you can later go on and change them. The way you do that looks pretty odd. You specify the name of the widget, then in square brackets as a string, the name of the property that you want to change, and you assign a new value to that property. So there's a demo here called Change Properties. Okay, and sorry, just looking at my cheat sheet to see where we're up to. Change Properties is this one. I'll run it first and then explain how it works, but it's similar to the example you saw me do before with pressing the button that said ouch, except that this one's using different widgets. In this case, we've got radio buttons. So the feature of radio buttons is you can select any one of them, but you can't select more than one. So in this case, we've got a big bit of text up the top. It says choose a text colour, red, green, blue, and when I select one of these radio buttons by clicking on it, the text changes colour accordingly. And if I click another one, it will go red, and otherwise it will go blue, but only one colour can be selected at a time. So these three radio buttons are all associated with one another in some way. So how does that happen? Well, here's the program that does it. It's not a big program, but there's a bit of messing about in here. So we create our window, we give the window a title. It's always going to be the same in all these tkinter things. We then create a label. So this big bit of text up here is a label, and we call it changeable label. Its text is choose a text colour, as you can see. It's 48 point times font, and it starts off by being purple. So the initial value for the initial colour for that text is purple. But then we've created, let me go down here, these radio button widgets. So each of these things here is a separate widget called a radio button, and it's got a number of properties associated with it, including the text that's displayed, the font, a command which is called. So in order to make these things active and do something, just like the push buttons, every time I click on a radio button, it's calling a function. In this case, the function is change colour. So there's a function defined up here called change colour, which decides what to do. Another way of solving this problem would have been to have three functions, one per button, but just for the sake of illustration, we've got one function here. And it looks a bit complicated because what this function does is when a button is selected, it checks a variable called label colour to see what value it has. Now, what is label color? Label color is an integer variable. This is a bit different than the way we've seen things in Python before, though. This is a tkinter variable, and so you actually introduce it by saying label color is assigned the value of creating an integer variable, int var. And down here, you can see in the radio button descriptions, we mention that the variable associated with these radio buttons is called label color. And all three of them refer to the same variable. Here's how they're tied together. Because if I select one of these buttons, then it affects the value of label color, which is shared with the other buttons. So that's why these buttons all have something in common. They've all got the same variable in common. And we've also got, for each of them, a value. Value 1, value 2, value 3. That means when I select this button, set the variable to that value, 1, 2, or 3. And that's what's going on in here, in the function that's called change color. It's saying, get me the value of the variable label color. And you can see that's done with a method called get. So you actually have to explicitly say, get me the value. You can also set the value. You can change the value. In this case, I'm saying, get me the value of the variable called label color. If it's 1, set the foreground property of the label widget to be red. If it's 2, set the foreground property to be green. And otherwise, it's got to be 3. There's no other alternative. So we set the foreground colour to be blue. And the label itself is just a standard label. We don't have anything clever about that. But we are changing a property of that label. Okay, so that's just by way of illustration of the way we can communicate values between different widgets. Now, I can see I'm running out of time, and I think we're just about at the break point anyway. But let me see where we're up to. Okay. Yes, okay, so this is the point I wanted to finish up on in terms of the first half of the lecture. User interface design. So once we start designing things like this that we have to interact with as human beings, you have to start thinking about how to make them convenient and useful. And this is not the topic of this unit. You learn this in other units involving design. But there are some basic principles that you can keep in mind about making things clear and so on. General rule down the bottom is the one I invented. I reckon if you need to put instructions on anything, then there's something wrong with it. It means it's poorly designed. So one of my favourites is, I travel on the train every day to get here, and the new trains have this amazing thing where if you stand at the door waiting to get out of the train, there's no doorknob. But if you look behind you, there's a button. You don't know what that button's for, but apparently that's the button that opens the door. Now, because it's so badly designed, the people at QR have had to put lots of instructions on this. First of all, they've got a little row of arrows here, so that if you're standing at the door, it tells you, oh, look behind you to find where the button is. And then it's got a label on it which says, push button to open door. Well, there's a doorknob here. I don't have any instructions for it, but I know how to use it. Because it's well designed. So doorknobs are not a complicated concept, but QR have managed to screw it up so badly that they have to explain to you how to open the door. That's a badly designed door.
Excuse me.
Yep.
Regarding the door on the train here.
Yep.
Someone pushed the wrong button.
Ah, yes.
The emergency
Yep.
open button with the label below it reading $300 fine for misuse.
Right. Which is actually what this little figure is about. Don't put buttons that open doors next to emergency alert buttons as well. So these people solved the problem with little yellow sticky labels, a smiley face and a frowny face. And again, if you have to put instructions on something, there's something wrong with it. Push and pull. This is always one of my favourites. If you want somebody to push on a door, not pull on it, you don't put a pull handle on it. You actually don't have a handle at all. You have a flat plate, so they have to push on it. And of course, everybody has this in their kitchen. I do this all the time. Turn on the hot plate. Oh, it's the wrong one. It's been heating up for 15 minutes and nothing's happened because I can't associate these knobs with these hot plates. I don't know which belongs to which, unless, of course, I read the little instructions below. Okay, I don't want to go into that in any depth, but you can see the point is that these things need to be well designed. If you're expecting somebody to perform a certain behaviour, give them the tools they need to do the job. Let's take a 10-minute break and we'll come back to talk more about tkinter user interfaces. Okay, welcome back. Lots of questions about assessment and so on. This slide doesn't have any significance whatsoever. It's just a final word on user interface design. Supposedly these are true. I can't believe it, but some people they claim they are. You never know what you can find. I've actually met builders and carpenters who probably would do the one in the middle. It wouldn't surprise me. Okay, so we need to think about user interfaces as we're designing things, but I'm not going to teach you that. You can figure it out for yourself. In other units you will think about how to design things so that they are user-friendly. But I want to give you the tools that enables you to create a user-friendly interface. So first of all, the most important thing is in all of the demos I've shown you so far, there was no control over the way the widgets were arranged in the window. Every time we created a widget, such as a button or something like that, I just said pack it into the window. And that's what's known as the Pack Geometry Manager. But there is actually something else we can do. So rather than, let me flick back a few slides, rather than having the default push me button as in that example, we can make some very simple extensions to our programs to have some control over, as I showed you before, the size of the window. In this case, the background colour of the window, which has been set to red, and the background colour of the button, push me, is also being set to red to match. What's interesting about this particular example, which I ran on this particular old Mac laptop, is to set the background colour of the button, I had to use something called highlight background. I don't know if that property applies to Windows machines or not. Maybe somebody can try it and find out. So the point is that we are, to some extent, getting into things that are a bit operating system dependent. So you might not want to get too carried away with using fancy or obscure features to make things look nice. Stick with simple things. Most of the things I'm going to show you from now on are pretty basic stuff that you can rely on finding in every standard user interface. But I'm sure you've all experienced the thing where you use an application, say on Mac, which was originally developed under Windows, and it looks terrible because the widgets overlap and the text sticks out to the right and things like that, because you do get these operating system differences, particularly with default sizes of text and things like that. So just keep that in mind. Don't get too fancy on trying to create user interfaces. Stick with simple things, such as fixing the size of the window. That's the geometry thing there, and colours and so on. Don't get carried away. Another thing that's done in this particular example on the slide is down the very bottom it says My Button, pack it into the window, and it says pad y equals 10. There are two very useful properties that most widgets have when you put them into the screen, pad x and pad y, which means put some space around it. So this is the same bit of code way back here. You can see there's no space allowed around the button. But in this next example, we've said pad y by, I think it was 10 pixels, was it? Yes, 10 pixels, which means put 10 pixels above and below this particular thing. So by default, you'll get all your widgets jammed together. To spread them out a bit, you can use pad X and pad Y when you pack them into the window, or, as these demos are going to show, you can use a different geometry manager. So geometry management in this world is really about controlling where the widgets go in the window. So with the pack manager that I've been using so far, it just stacks things normally vertically in the space. So when I ran that example before, let me find display bits, that's the one. Display bits, I didn't say anything about how I wanted the widgets to be laid out, but when I created the program, okay, and it popped up like that, we had 3 widgets in this little window, the place where the digits appear, and the 2 buttons, 0 or 1. Why did they appear in that order? It's because this is how we inserted them. I said display pack, button 0 pack, button 1 pack. Pack means stick them in the window using the default layout. And the default layout in this particular system is to just align them centred and vertically. If I resize the window, you can see they just stay there in the middle of the window, stacked one on top of the other. Yep.
With the pad X and pad icon, say you wanted to shift your button so it's
Yep. No, so the question was, can I have a different size above and below when I'm using pad Y? One of the things that I find frustrating about pad X and pad Y is they're fairly crude ways of separating things out. You just get that fixed amount on either side or above and below. So for a quick and easy fix, they're a good way of doing things, but they don't give you much control over how things are laid out. And you'll find in real programs that look nice in terms of their user interface, they're probably not relying on something that simple. They're doing something much more complicated. It's the other point about GUI programming is getting the graphical user interface to look nice and be laid out nice and have wonderful colours and so on can often be more code than the thing that actually does the work. So the front end can often be bigger than the back end. I'll say something about front ends and back ends in a moment. If you don't like just having things stacked up vertically like that, you've got two choices for different geometry management solutions in TK-Inter. One of them's called the Grid Manager, the other one's called the Place Manager. I'll do the Place Manager first because it's the simplest one. For you guys, you've been playing with Turtle Graphics and you've been using a coordinate system. Place management works in exactly the same way. It says, put this widget at these coordinates. Now, the only thing that's different is the coordinate system that's used by default here. Here's my place demo. Has 0, 0 up the top left rather than in the middle of the screen. So if we look at this demo, it just doesn't do anything. It just displays these three coloured shapes. But as it says in the caption up the top, the coordinates start at the top left corner. So or relative to the top left corner, and they go positive down and positive to the right. So this label, red, is at position 2020, and if you look in the code here, it creates these three labels, red label, blue label, green label. They go into the window called place window. They've got the text and the colours and the sizes and so on, the width. But the important part here is this part. When we place them into the window, instead of saying pack them into the window, in this case it's place them into the window, and we specify coordinates. So the red label is at location 2020. So 2020 is actually where I'm putting the cursor right now. It's that top left-hand corner. So I'm saying put the red label there, put the blue label at 7050. So 7050 is where I've got my cursor now, and 12080 is where I've got my cursor there. So this is pretty easy. You can just specify exactly where you want to put things. However, I don't recommend using the Place Manager very much because it doesn't really take into account how big these things will appear. If I change the sizes of the text in these labels or something, I'm going to get problems. And very often when things overlap in graphical user interfaces, it's because somebody has fixed their location, not taking into account that on a different operating system, they get a different size of text and so on. So place management is to be used fairly cautiously because it might look great on your computer with your particular screen resolution. It might not look so good on somebody else's computer if they're running a different operating system or have a different screen resolution. So I tend to steer away from the Place Manager as much as possible. The Pack Manager, of course, is just too basic. It doesn't give us much control. The one that is the best compromise between the two and the one that's the most useful is the Grid Manager. So the Grid Manager pretends that the screen is laid out into rows and columns, and you specify which row and which column you want the various elements to appear in. So it's very much like filling in a table. And that's, you think of an invisible grid, and you just specify, I want this widget at this row and this column location. So there's another demo here, which doesn't do anything, but it shows a grid. So here's the grid demo. So a lot of pre-packaged demos in this lecture, but it's because they take too long to type in. So let's see if we can figure out what's going on with this one. I'll just run it so we can see it for a start. Okay, so it says 3x3 grid demo. And it's actually got something we haven't seen before. It's got a text entry box. You can see the cursor flashing in there. It's waiting for me to type something. It's got a legend that says, enter your name but do not expect a response. So I type in my name as Fred Flintstone. Never give your real name. Okay, and then there's a button that says done, so I better press the button that says done. and of course nothing happens because it says don't expect a response. We haven't defined what to do with the name. But the real point of this is that it is a 3 by 3 grid. This is the first column, this is the second column, and this is the third column. And this is the first row, this is the second row, and this is the third row. So if we look at these text entry boxes and the button, hopefully I can see that a text entry box is what I've highlighted at the moment. It's somewhere where you can type in text, and your program can get the text from the text entry box, so it can read the text that you've typed in. This one doesn't. But here it says somewhere, create the 2 text entry boxes in the third column, and they're in rows 1 and 2. So this is the one I've highlighted here with Fred in it. That's in row 1, column 3. And the next one with Flintstone in it is row 2, column 3. It's that simple. I haven't specified how wide the columns are or how deep the rows are. That's just all been left to the defaults. So as you can see, again, it's just filling things in to fit the widgets. I could try to put pad X and pad Y to get some more space around these things. But the basic point here is that where I've got my cursor at the moment, that's row 1, column 1. That's row 2, column 2. The button is put into row 3, column 3. There's another thing that we haven't seen before, sticky. Sticky means stick to one of the sides of the surrounding cell. So in this case, sticky equals E means stick to the east edge of this particular window. So it's just specifying rows and columns positions and leaving everything else up to the geometry manager. These 2 bits here, first name and surname, they're fixed text, so they're just labels. And so those labels similarly appear in row 1, column 2, and row 2, column 2. So that's straightforward. There's nothing in row 3, column 2. What about this bit of text here, though? Enter your name, but do not expect a response, because it goes across 3 different rows. So the way that was done, here's the message, text, enter your name, but do not expect a response. It's placed into row 1, column 1, so you would think that would be up the top left here where I've got my cursor, but then we've said row span equals 3. So you can specify where it starts, and it can span a number of rows, as in this case, or a number of columns. And so that's how you can get things to occupy more than one cell in this imaginary grid. The other thing to point out about the grid is that you can start the numbering anywhere you like. In this example, we started counting from 1. You might want to start counting from 0. It just uses the smallest number you specify as the starting point, and the largest one as the finishing point, so you don't have to stick to a particular numbering scheme, but it's probably a good idea to start counting from either 0 or 1. And beyond that, everything else is just given a default size. I'm pretty sure, but I could be completely wrong, that in examples like this, it makes the 3 columns the same width. So there'll be the width of the widest thing that fits into them, and probably the same for the rows. I don't know what happens if I pull this window open. Nothing. Okay, so they're all just fixed into something that size. And if I try to squeeze it up, it just covers things up. All right, so they're not moving at all. Unlike the example with the pack manager where you saw the thing stayed in the centre, no matter how big the window was. So the grid manager, I personally think, is the easiest or the neatest way of arranging your widgets. And the other thing that's very useful is to put them into frames. If you've got several widgets that are related to one another, you create a frame object and do what was shown on this image way back here, where the 3 radio buttons are all placed into the same little box. So they all sit together, and you can treat that as one widget. And so you can specify where to put that box containing other widgets. It's like a window containing sub-windows. That's another very useful way of grouping things and arranging them when you're designing your user interface. All right, so that's all there is to geometry management. I think most of our following examples do use the grid manager. Okay, I think I've said all of those things. So looking at the examples that are coming up. Oh, okay. All right. Movie type chooser. Okay, movie type chooser is just another example of how you can have communication occurring between widgets. It's a rather silly example, but I don't take the blame because I got it out of a textbook. So let's do movie type chooser. And the other reason for bothering to look at it is it's got some different widgets that we haven't seen before. So again, I'll run it first and then look at how it works. F5, here's the little TK Enter window. It pops up, it says Movie Chooser. Choose your favourite movie types. And you can see here we've got some buttons, but these ones are check boxes. So they're not radio buttons as we saw before. With these ones, I can click on them and then toggle them from being checked or unchecked. So if I click on drama, it says you like dramatic movies. If I click on romance, it says you also like romantic movies. And if I uncheck the box, the text goes away. You like romantic movies only. You like action-packed movies. Drama again. You like comedic movies. I like all sorts of movies here. What if I don't like movies? Well, I uncheck the boxes. You can see the text is going away and it says you don't like any kinds of movie. Something wrong with you. So, how did that work? We've got a text area here which is displaying text that's yellow, and we've got these three buttons. How does it all connect together is the question. So first of all, we've got, let me just quickly resize this. Okay, this is not the only way of doing this, I have to emphasise, but this is how this particular example works. We've got a lot of stuff here. It looks very complicated, but it's not. It's just specifying where these things are and what they are. So we've got our 4 check buttons. In this case, we haven't given a name to the buttons. So I haven't assigned them to a variable because we never refer to them again. We've just got these 4 check buttons where they all belong in the window. They've each got some text associated with them: comedy, drama, romance, action. The other thing that's different about this example compared to some previous ones was because I haven't given a name to these buttons, I can't refer to them by name. So how do I put them into the window? Well, in this case, we've just followed the description of the button with a dot, which means we're using dot notation. We're saying call the method grid to place them into the window. So if you're never going to refer to a widget again, you don't have to give it a name. You can just do this trick. So it's slightly shorter, but perhaps a bit more obscure. I wouldn't necessarily advocate it. But in this case, it's just saying, oops, if I could get a hold of that, I want to create a check button containing the text comedy, and I'm going to use grid geometry management to put into row 1, column 0, that's apparently there, and stick to the west-hand side of the cell. So that's why all 4 of these buttons stick to the left, because we've said make them sticky on the west side. And otherwise, all 4 of those buttons are the same. I'll come back to them in a second. What about this text down here? Well, that text is created by a text widget. So a text widget is a general purpose widget containing text. It's like a little editing window. I'm not sure with this one whether I can edit this text. Yes, I can. I can go in there and edit that text. You can stop that from happening by saying this window will not take the focus of the cursor. But in this case, I've completely messed up the text in here, but I can fix it up again by clicking on those buttons. So the text widget is a general purpose window where you can put text in. This example puts text into the window. You can also get text back from the window, but I haven't used that for this particular example. So it's like a little text editing window. And you can make these fairly complicated as well. So the big question, though, is when I click on the buttons, how does it update the text? How does it know what text to put in there? What's really going on is, again, similar to the example I showed you before, each of the check buttons has a variable associated with it. This time there are 4 of these variables. One called likes comedy, likes drama, likes romance, likes action. Again, those variables are introduced as special TK-Enter variables. This time Boolean var rather than int var, which means they're going to have a true or false value, which is what you would expect with a checkbox. It's only either on or off, true or false. So there are 4 of those. And when, where's the thing? Okay, and there's a command associated with each of the buttons. So again, each time I change a button, it's going to call this function to update the text. So the function is called, of course, update text, and here it is. Function called update text gets, so get is the way of retrieving the value of each of the buttons, and just for effect, this particular one gets each of the 4 values, So there'll be true or false values, and it puts them in a list. So we've got a list of 4 values, true or false, called users likes. And then we start manipulating the text in the box. Although you can't see it because it happens so quickly, whenever I click on one of these buttons, it actually clears the text out of the box. It deletes everything in there. And that's what's happening on this line. The results text is the text widget, and it says delete. What do you want to delete? We have to specify where you start and where you end. And the notation is a bit odd and eccentric. The starting point, the top left-hand side of the text, is 0.0, and the finishing point is end, which is a constant that you need to import. So this action says delete everything in here. So every time I click on one of these buttons, it's actually deleting all of the text and replacing it. And it replaces it by saying if the value true doesn't appear in any place in the user's likes, so this is a person who doesn't like any movies, the text that you then insert is you don't like any kinds of movies. So if I unclick these, that's what I get told. You don't like any kinds of movies. Otherwise, if I click on one of these, it says if the value at 0 is true, then put in you like comedic movies, 1 you like dramatic movies, 2 romantic, and so on. So that's the way it's really working. I think that's about all we need to know about the movie chooser, so let's move on from that. So again, it's just an example of a different type of widget you can use, checkbox widgets. Another one that's good, I'm not going to get around to doing it in time, I don't think, is list boxes, unless there's one in here. Oh, I think there's one coming up, actually. Where are we? Periodic table. Okay, so I'm going to rush into another show and tell demo. Let me just check my slides, though, and see what's coming up. Front and back ends. Okay, so front and back ends, I've already mentioned this concept. When we're playing around with these user interfaces, it's very common in programming and software development to divide the work up. And towards the end of the semester, I'll come back to this topic. And as you've seen, creating these graphical user interfaces is very fiddly. There's lots of specifying positions and colours and all that sort of stuff, very distracting. And so what people do is they divide the work up by having somebody working on the front end part, that graphical user interface, making it look nice and so on, and somebody doing the important stuff, which is behind the scenes, which is the part that actually does the calculation. And very often the part that's behind the scenes will be interacting with, as we'll see in subsequent weeks, a database or some sort of file server or some other source of information or computational power. So most non-trivial IT applications are going to have typically a front end separate from the back end but communicating with it, and sometimes in the middle there might be a very complicated computational component if it's doing some sort of number crunching exercise or something like that. So front ends, back ends, central computational parts, they're the ways in which you can divide the work up. And when you're developing stuff, I would recommend that you do that as well. If you've got to do something that does some work and has a fancy front end, don't try to do it all at once. I would normally recommend doing the back end first. Get the job done, the part that does the important work, then put the fancy interface on top of it to make it look nice. But don't try to do everything at the same time. And certainly, for me, starting with the front end is a bad idea, because you've then got to try to somehow graft the back end onto the back of it. So trying to keep those things separate is always a good idea. An example just to demonstrate the difference between front ends and back ends, in fact all of these remaining examples are like this. This one called periodic table. Okay, so this is just a little application that allows me to browse all of the elements in the periodic table. And so here they are, element details. And as you can see, it's a long list. It's got the symbol, the name of the element and its atomic number. And so it's a very long list containing triples, a bit like the mini database thing from the previous week. So we've got a list containing all of the details of the elements in the periodic table. We've got another list which is all of the element names in alphabetical order. So you can see all of those names appearing alphabetically. And so, so these two lists are part of our back end. Our back end is the list of elements. And then we've got our front end, which is the tkinter part. The tkinter part is going to create an interface which will enable us to develop, explore what's in the periodic table. So let me start it up. here we go, Element Browser. So this has yet another sort of widget that we haven't seen before, one of these drop-down lists. So what is this list? It's a combo box, okay? A combo box is a thing that allows you either to select items or to type items in. So if I click on this, I get a little drop-down thing with the names of all of the elements in alphabetical order. That's what that other list was for. That was the list of alphabetically sorted elements. And if I pick an element, such as tin, and then click this button display, it shows me the symbol for tin and its atomic number. And that's all this really does. It just allows me to pick things, potassium, display, I get the symbol and the number, and it allows me to do that for all of the elements, including some of the rarer elements, such as dilacanium is a very high atomic number. Another rare element that's in the list is kryptonite, okay, that's 120. So it's got all of the elements, including some that we don't commonly see. But the basic point is that I've got a widget for selecting things, and then I've got an interface to the back end which contains the information. So if you look at the way this program is structured, this is the front end. So actually what's on the screen right now is the front end part, the tkinter part, which creates these three little widgets. It's actually using pack management just to be lazy. So it creates a combo box widget. So we haven't seen those before. Combo box is this thing here. Okay, I can type things into this box. So I can type in the element thing and try to display that, and I get 0 coming out. Or if I type it incorrectly, I could type in tin, and I get back to where I was before. So combo box allows you to type stuff in or pick stuff from a pull-down menu. And so the combo box has to have values associated with it. So a property of a combo box, of course, is what is in the menu. In this case, it's the element names. So that's why we had that list of alphabetically sorted elements up here. That's element names. So each of those elements is one of the choices that appears in the menu. So that's our first widget, is the combo box. The second widget in the list seems to be where I display the results. So this is where we display the element name and the atomic number. It's just a label. So we're playing the trick here of changing the label property each time somebody selects something. And the part that does the work is this push button, which allows me to, having chosen an element, that is a real one, you get the label updated. So initially the label doesn't have anything in it when you start the program, but every time you pick something, the label does get updated accordingly, similar to the example that we saw before. So there are three widgets. They're just packed into the window, and that's our front end. We've got a central part here, though. This is the central computational part that does the work. So in this case, there's a function called getElementDetails and another one called displayChoice. Now, displayChoice is the one that's called by the front end. So when somebody clicks the button, we call the function displayChoice. How does displayChoice work? Well, it looks in the list of names, that's the combo box, names list, and it does a get to get whatever is currently being selected by the user. So if I select something here, if I highlight rhodium, that is what will be returned when somebody does a get on this particular widget. And what do we do with that? Well, we look it up. So we've got this function getElementDetails, which, given the name of an element, goes through a list. Remember from, what was it, last week? For symbol, name, number in element details. We're just going to go through each of the things in this long list up here. So we're picking them out one sublist at a time, and we're dividing them up into the symbol, the name, and the atomic number. Okay, so it's almost exactly the same as the mini database example from last week. What do we do with each of these? Well, we've got a for loop which looks at each one and it checks to see if the name it's just encountered in the list is equal to the name we're looking for, and if it is, it immediately returns a result. And in fact, in this case, it returns a list containing just the symbol and the number because they're the things that we're going to display. Otherwise, if we get all the way to the end of the list and we didn't find what we're looking for because somebody typed in something stupid, like stupidium, we get a 0 and 2 hyphens, and this is where they come from. They're the results you return if you didn't find the element in the list. So these two functions together are our central computational part. We've got our GUI front end, computational part to do the work of looking up the names, and the back end is just this long list of information about the various chemical elements. So there's manganese, and if I can find it in the list, where is manganese? Display MN25, and that's exactly where it came from. We searched through the list until we found it, and when we did find it, we updated the label to display it. Did I show that? No, I didn't. So once we get the element details, we just update the text in the label and make it look nice by adding some spaces and so on. So pretty good example of front-end, computational part and back-end, and all creating a nice little GUI. Very last example I'm going to do, because this is all just about different ways of displaying stuff, is the one called the used car database. So it's not actually a database. We're going to do databases later in the semester, but at the moment this is just a big file. So remember on the previous slide it said you can use a file server as a database. Well, that's what this example does. So I just wanted to finish with a bigger case study involving front ends and back ends. So the thing up the top right is the database. It's actually a comma separated file which contains lots and lots and lots of boring details about cars, including their make, the model, the year, engines, size, tank capacity and so on. But these we assume are cars that are up for sale, and we want to provide the user with a friendly user interface for browsing that collection of data. So if we look at the collection of data, he says, we go into here. This is where the used car details are to be found. I'm just going to open this up with a text editor if I can. No, I can't. It wants to open it up with Excel, but I don't want to play around with stupid Excel. So let's open it up with a text editor. Okay, so this is what's in the database, supposed database. It's not really a database, it's just a file containing plain text, but you can see you've got all of the information in each line for each of these cars. And the important thing is it's a CSV file. CSV stands for comma separated values, and as you can see, each of the different fields in each line or row is separated by a comma. So my Python program has to read this as the source of information, this big file. By the way, the reason for doing this is that this really is a big file. It's got about 3,000 entries, something like that, something ridiculous. So we need a user interface to allow us to explore in a meaningful way this collection of data, and that's what the used cars program does. So used cars is a GUI program that is going to provide a nice user interface to that big data set. And so if I run it, it comes up with something. Here we go, used car search. And so used car search is a little graphical user interface for viewing that data, and it asked me for a few things: minimum price, maximum price, and preferred make. So I can specify the characteristics of the car I want. Let's say my minimum price range is 3,000, maximum is 35,000, I'm making this up, and we want a Holden. There won't be many Holdens left soon, but we want a Holden in our particular search now. So I press the button search, and stuff comes up. Matching Holdens found. Premiers, Monaros, Kingswoods, not the Kingswood, Tiranas, and so on. And I get a whole bunch of these. And you can see there are actually a lot of results returned in this particular case. What if I changed my mind and didn't want to go for a Holden? Let's go for a Toyota. A Toyota's a Toyota. And we get matching Toyotas found, including a Land Cruiser. What if I narrow my price range? So let's say I want something between 30,000 and 35. That's a much narrower range. So I'm going to get fewer results there. Still a lot. Let me make it even narrower. And so let's make it 33 to 35. Okay, and still a lot of Toyotas in the database. Let's make them Mercedes and see what happens. Mercedes, search, no matches found, not in that price range anyway. Let's make it 135,000. Search, still nothing. Okay, so I don't think there are any in this database. What do I do? Put in Ford. Let's see if we can find Fords. Yeah, plenty of Fords, Fairlanes, Fairmonts, etc., etc., etc. So how does that work? It's certainly more convenient than searching through that text file, but of course we need to do some programming work to make it happen. So we've got exactly the same situation. We've got a back end, front end, some stuff in the middle. So the back end is really this part here. This is the part that searches through the text file. So you can see it's a fair bit of code to do that. It's a function called getCars, and it gets from a widget the make of the car, and from another widget the minimum price, another widget the maximum price. So it's talking to the front end to get the details that I've entered here. And then it opens up the text file, which I've lost. Where did I put that? It's there. No, not that one. I've closed it down. Where is my text file? Sorry, I've got to do this again because it's not the default app. Okay, there we go. Right, so this is what it's actually working with, is this text file containing all of this stuff. And so it needs to extract each of these individual lines describing a car. The way that works is, having opened the file in universal mode, the U means I don't care whether this was created under Microsoft Windows or on a Mac or under Linux. We just open it up. Then we've got our list of results. Remember that the results that are returned here are a long list of values, so we need a list to accumulate the results. And then we go through all the details for each car. For each car in the car details file, that will give me one line of text. How am I going to break this up? Well, it's all one big blob of text. But the key thing is it's a CSV file. Each of the fields is separated by a comma. So I can just use the split function specifying that I want to separate on commas, and that will return a list of individual character strings. So this one will become the character string 14895, followed by Datsun, followed by 180B, and so on. So they've now got each of those teased apart in a list. Do we then extract, using a very compact statement, the car ID, the make, the model, and the price, because those are fields 0, 1, 2, and 4 in this list. And we then check to see, is it one that we're looking for? Is it a make that we want? Is it within our price range? And if it is, we append it to our list of results, formatting it at the same time so that it will come out with a colon there and a $sign there and so on. And at the end of doing that, we're going to put it into this space here that I'm scrolling through. So you just notice Datsuns. Let's change it to Datsun. For some reason, search, no matches found. Wow, they must be too cheap. Okay, search. Gee, where are my Datsuns? There we go. Wow, not many Datsuns in the database, and they all seem to be pretty cheap. There we go. So only $4,000 or $6,000 for Datsuns. But the point is that we go through each of the things in that database or file. We look for a match, we append it to our list of results, and then we put the results into this text area where I've got my cursor now, and that's done in the same way as the previous example. We delete the contents, and then we either put in the phrase no matches found, or we have a little loop which goes through each of the results and inserts it into the box. So all of this is the back-end stuff that's accessing the car details file and getting the results out of it. What about the front-end stuff? Well, that's this GUI part here. So separately from that, we've got the graphical user interface, which looks like this. What about this bit here? Used cars safety tested. Well, that's just a label. So like the pop-up example at the beginning, it's a label which has a photo image in it. So a photo image is another type of widget. In this case, it's just coming from a file called usedcars.gif. So if I go in here, there it is. That's the file that we get this image from. So we're putting that in as a piece of text, and then we put that label into the window using the grid manager. So you can see we've used the grid manager throughout here to place things nicely, to line things up so they look good. So we've got the labels lined up with the text entry boxes and so on. So a bit of effort's gone into laying this out so that it doesn't look too bad. But the parts that do the work are the results area, which is, again, is a text box as I had before. So that's this big space here. It's a text box where we insert the results of the search. And the other parts that are important are entries. Text entry boxes are these things, where I can enter text, and having entered text, the functions can get the text that's inside the boxes. And of course there's a button. So the button says, call the function get cars, the back-end function, every time the button is pressed. Let me just make these even cheaper. Can I get another matching Datsun? Yes, I can. Datsuns are really, really cheap, it turns out. So, putting all of that together, it's quite a big program, as you can see, just to do that fairly small job. A big back-end function and a fair bit of GUI code as well to make this look nice, which leads me to the very last observation, which is something one of my colleagues said when we were teaching this using Java, which is that GUI programming isn't hard. The only thing that is hard about GUI programming is GUI programming, because it's just so fiddly. But it's not conceptually difficult. It's just a matter of specifying lots of shapes and colours and positions and sizes. And it makes the code look complicated, but it's not really fundamentally complicated at all. All right, that's all we've got time for this week. Keep working on assignment 1 because it's due in only 2 weeks from now. And otherwise, I'll see you here next week at the same bat time, same bat channel.